Hello everyone, this is Divya. In this session, we are going to discuss about the topic role of modulation technique in the evolution of wireless communication from 1G to 5G. The contents we are going to cover in this topic are role of modulation, evolution of the modulation, technique, impact, and future development and challenges of the wireless communication. First, we are going to discuss about the role of modulation technique in wireless communication evolution. So basically, modulation techniques plays a crucial role in wireless communication by encoding the data into radio waves for transmission. With each generations of wireless technologies and advancement in the modulation techniques have been instrumental in improving data rates, spectral efficiency and overall performance. The evolution from 1G to 5G has seen significant changes in the modulation techniques to meet the increasing demands of users for faster and more reliable communication. And the next is evolution of modulation techniques in 1G. Usually, 1G wireless communications primarily used analog modulation techniques such as frequency modulation and the amplitude modulation. These frequency and the amplitude modulation techniques were limited in the data capacity and susceptible to interference and leading to lower quality and it can be reliability in the communication. These transition from 1G to 2G, it can be marked a shift toward the digital modulation techniques for the better efficiency and the performance. In this picture, we can see that the generations and the transition from 1G to 4G data communication. And in the 1G, we can see the features of the 1G mobile phones. That is, it is only the basic voice service and it is analog basic protocols. And it can be the speed of the 1G mobile phones 2.4 kilobytes per second. And the 2G generation mobile phone features that it can be designed for voice and it can improve coverage and capacity. It is the first digital standard that is GSM and the CDMA and the speed of the 2G mobile phones are 64 kilobytes per second. And the next is 3G. It is designed for voice with some data consideration that is multimedia, text and internet. It is the first broadband and the speed of the 3G mobiles are 2000 kilobytes per second. And the next one is fourth generation. It is designed primarily for the data and IP based. These are the IP based protocols. It is a true mobile broadband. And the speed of the 4G mobile phones are 100,000 kilobytes per second. And next is advancements in the modulation techniques in 2G. 2G introduced digital modulation techniques like GSM using Gaussian minimum shift keying. We can call it as GMSK for improved spectral efficiency. GMSK allowed for higher data rates and better resistance to noise, enhancing the overall quality of voice and data transmission. The adaptation of the digital modulation paved the way for further enhancement in subsequent generations of wireless communication. In this picture, we can see the digital modulation techniques and the different types of digital modulation techniques and their waveforms. This first one is the baseband digital message signal, and next is analog sinusoidal carrier signal, and the next is ASK, that is amplitude shift keying, and next is FSK, frequency shift keying, and next is PSK, that is phase shift keying. Impact of modulation techniques in 3G evolution. 3G networks utilized more advancement modulation schemes such as quadrature phase shift keying, that is QPSK, and quadrature amplitude modulation, that is QAM. These techniques enabled higher data rates and improved the spectral efficiency, supporting multimedia services like video calling and mobile internet. The evolution of modulation techniques in 3G laid the foundation of the transition to faster and more efficient the 4G networks. Transition to advancement modulation techniques in 4G. 4G networks employed sophisticated modulation schemes like 16 quadrature amplitude modulation, that is 16 QAM, and 64 QAM for increased data capacity and faster speeds. These techniques allowed for higher throughput and better performance in data-intensive applications such as HD video streaming and online gaming. The use of advancement modulation techniques in the 4G contributed to the seamless delivery to high-speed mobile broadband services. Next is innovation in modulation techniques for 5G networks. 5G networks leverage cutting edge modulation techniques like orthogonal frequency division multiplexing and filter bank multi-carrier to enhance the spectral efficiency and network capacity. These techniques enable 5G to support massive data traffic, ultra low latency, and reliable connectivity for emerging technologies like IoT and autonomous vehicles. The evolution of the modulation techniques in 5G is driving the next wave of wireless communication, revolutionizing how we connect or communicate in the digital age. And the next is the major challenges and opportunities in the modulation techniques for 5G. The implementation of advanced modulation techniques in 5G networks poses challenges in terms of complexity, power consumption, and signal processing requirements. However, these challenges also present opportunities for innovation and optimization to further improve the efficiency and performance of 5G communication systems. As 5G continues to evolve, ongoing research and development in the modulation techniques will be crucial in the realizing the full potential of next generation wireless networks. Future direction in modulation techniques for beyond 5G. Beyond 5G, modulation techniques are expected to evolve towards more adaptive, flexible, and efficient schemes to meet the evolving demands for wireless communication. Technologies like machine learning and artificial intelligence will play a significant role in optimizing the modulation techniques for future wireless networks. The convergence of the advanced modulation, beamforming, and the network slicing will shape the trajectory of the wireless communication beyond 5G, unlocking the new possibilities for the connectivity and the innovation. Now we came to conclusion of the topic. Modulation techniques have been instrumental in the evolution of wireless communication from 1G to 5G, driving advancement in the data rates, spectral efficiency, and overall performance. Each generation of wireless technology has witnessed significant improvements in the modulation techniques to meet the growing demands of the user for faster, more reliable, and connectivity. The future of the modulation technique, that is the wireless communication, will be continued to be shaped by innovations in the modulation techniques and paving the way for more connected and technologies advances. Thank you.